Hi and welcome to this webinar, which will be about preparing and optimizing 3D models for use in CityPlanner. Since this webinar is live, you can ask questions in the live chat if there's something you want to ask us, and we will try and answer them during the webinar. My name is Johan Göransson, Product Manager for Agency 9, and I am joined today by our friendly community manager and 3D expert, Karin Schött.
Hi.
So Karin, why is it so important to prepare and optimize 3D models before you use them in CityPlanner?
I will tell you. Since CityPlanner is a cloud service, it means that all the information on the screen needs to download for each single user. That means if some viewers are having a lower performance device or a slow internet, it will run slow. So this is why we have to optimize those big 3D models so they run smooth in CityPlanner.
Right. So it's when it comes to performance, it's really two things we need to consider. It's both the downloading performance, how long time it will take for our 3D model to download to the end user, but also rendering performance. How well does this model perform or render in the scene? Because the scene is not only the individual 3D model, it's also the surrounding 3D world, the terrain model, trees, existing buildings, etc. So it's super important that each part is as optimized as it can be to ensure an overall smooth experience.
Yes, and we're going to start by showing you some different types of level of detail in CityPlanner. The first one here is a volume study. This is not giving too much information away to the viewer, and you can use it in early stages in the planning. You can also use the 3D library here to draw your own models directly in the scene. So volumes. Next one is solid model, as we call it. This is a higher level of detail. It shows the surface of the building without any textures, and it has a really clean graphical output. So you can use it on, for example, OpenStreetMap backgrounds. Next level is multicolor. These colors distinguish the elements from one another, and here you can also use transparency to improve your details. No textures are used here either.
So this model is actually very, very light as well. It's as light as the model
Solid.
with just one color.
Yeah. So the last level is a realistic model. This contains realistic materials, bitmaps of raster images. This model is optimized and it contains, for example, transparent PNGs, as you see here, as a replacement of a high polygon object.
So which level of detail, how do you know which level of detail is right for my project?
It's depending on what you want to show, how much you want to show to the viewers, and what stage you are in your planning, for example. So as I said, volumes are really good in the beginning, and then later on, the more detail you have, you can upload your complex models. And here we have the options to upload models. They are KMZ or Collada files. And to do this now, we're going to continue with Sketchup. Sketchup is a freeware program. It imports a variety of 3D models, and now we're using SketchUp Pro, which is a little bit better than the default version because it doesn't import as many formats as this one.
So a typical scenario would be I have received a DVG file or a 3ds file from an architect or external consultant, and then you would just import it into SketchUp, or how's the workflow?
Exactly. This model is an example that I got from an architect. This is what we called a complex 3D model. We're going to view this by looking in the model info here. So this gives us a lot of good information of what the scene contains. statistic here shows edges, faces, components, and groups. And this number here is quite important. This is 120,000 faces in this model. And we want to reduce those so they are getting a lower amount.
So faces, that's the geometry, that's the surfaces in the 3D model.
Exactly. So we're going to start by viewing this model here. If I put on wireframe, for example, I can see the interiors, and we see that this contains furnitures, which is unnecessary for the scene since we just want to visualize the external model. So by clicking on those furnitures, we can select those, and they are grouped already, which is good. So if you look now at the number of faces here when I'm deleting those objects, it goes down to about 50,000 drops in faces. So this is good. So try to stand in the top view, look in the model, what's it containing inside, if it's any unnecessary furnitures or whatsoever that you can erase.
And if you're really lucky, they might be in a layer if you have a structured model from the start.
Exactly. So you can select by layer, and then you can just take all the layers that are, for example, internal furnitures away. But the most common case, as this one, is that everything is in the same layer, so you have to have other options of selecting objects in the scene. So we continue with this model here. We see that we have balconies, for example, which is a typical high poly object. Contains a lot of cylinders, which is unnecessary for this one, and it just takes a lot of power to show them. So we're going to start by selecting those groups here. We're going to erase those, and we're going to see that the faces are dropping now to 60,000 about. And what we want to do, we want to replace those balconies with transparent PNGs. So I will show you how to do this. First, we draw new rails. Like this. And then we go to create a new material. And this is where we're choosing the transparent PNG. I made this before here. We're going to open it. We're going to give it a bigger scale. And as you see here, it's white and black stripes. By applying this new texture to those objects, and you can see that it looks like 3D rails, but it's actually just a 2D raster image.
And it's basically, we went from maybe 10,000 faces down to 3.
Exactly.
So that's quite an optimization. And that's just for one balcony object.
Exactly. And then by doing this on all the balconies, we can fast just replace those. And as you see, we have some other types of balconies down here, so you need to actually manually replace those as well. But we're going to go to the next step here. So another component in SketchUp is an instance. An instance is a reference of each other, you can say. So by changing one, all will be affected. So let's try this. Let's double click this window and select all the unnecessary geometry on this window. I delete it, and as you see, all the windows are getting affected in the same way. I'm choosing to put a transparent color on this one, since it's a window. And you can also look here in the faces amount that it's now under 60,000, which is good.
So general or typical objects that use this method, what would you say that would be? Maybe trees?
Yeah, exactly. Trees are usually full of also unnecessary polygons and a lot of branches, for example. So those you can replace or just take away. And in CityPlanner we have 3D library here which actually contains pre-made trees that are already optimized, which is really good to use. And also other instances can be stairs, for example, different kind of roof components, and other detailed.
So definitely one quick optimization you can do is just replace stuff that's not necessary for the scene, like the interior, but maybe also trees, maybe lampposts, that sort of things.
Exactly.
Because they add so much geometry to the scene.
Yeah, and as you see here, as I'm erasing those balconies here, we're getting a lower amount of faces. So this is our examples of why we recommend how to optimize complex 3D models.
Right, so we went from 126,000 something faces down to 26. So with these quick steps, we just removed 100,000 faces from this model, which is great because as we mentioned in the beginning, it's not only going to be this building, it might be 4 other buildings as well, and the surrounding world with the terrain model, the existing buildings, maybe trees, etc.
Yeah. Another thing here is with transparency that you should consider the transparency, because sometimes the house can be hollow, means missing floor plans, for example, which gonna look a bit strange when you view it from the outside, because then you're not gonna see any floors inside. So make sure that if you make transparent windows, you want to have floor plans in the house.
And another thing to consider when it comes to transparent surfaces is those actually have quite an impact on rendering performance. So if you have a lot of transparent surfaces, you might get a slower rendering of that model. So make sure to only use it when there's a purpose.
Exactly. And the next step here is textures, actually. So this model that we got from the architect already had textures in it. And as we see here, it's realistic wooden things, and it's bricks. And in SketchUp, you have all the materials and textures here. So the problem can be that we have some really heavy ones that we want to edit and configure to make smaller. So we're going to do the example of this one, how to easily overview your model to see which textures are the heaviest ones. We're doing this by exporting this one to a Collada file. DAE is Collada. And I already made it before. So here is our Collada folder. This contains a 3D model here, and also a folder with the textures. And in this one, I have all the textures that's in my scene as well. So here I can easily see the size of them and the ones that are too big to perform good in CityPlanner. So I can open this one, for example, and I see that this is some kind of green grass, and it's way too big. And it's also have too much information, since this picture could be just a tenth of the size here.
Because it's basically just a repeating pattern.
Yeah, exactly. So in this case here, you need an image editor. And we usually use Photoshop for this to lower the amount of pixels in the picture. Or you can use freeware programs as Paint or GIMP or other programs.
Yeah. So it's important here because the size of the images are totally fine because they are JPEGs, and that's good. They're compressed. But the resolution of these images, some of them are way too large for the visual impact they will have on the model. So as you can see here, the resolution of that grass texture or this brick texture is way over 1,000 pixels.
So what do we recommend?
Well, I mean, as always, it depends on what you're trying to communicate, but a general rule of thumb is no larger than 1024 by 1024 pixels. Because in general sense or general visualization, people don't really zoom that close into a brick wall and study the exact texture of the thing. So
exactly. And here those textures, they are actually not too big, and they look good in the scene. So
that's super important, because the resolution, even if the images are compressed with JPEG, so they will transfer quickly. But when CityPlanner is going to render them, it will have to unpack those pixels to an uncompressed format in the video memory. This is a bit technical, but so they will be treated like uncompressed images in video memory. So that's why resolution matters.
Yeah. We're going to continue with SketchUp a little bit here, and we're going to look at some extensions. So SketchUp is working with something called Extension Warehouse, where you can download different kind of tools to help you improve the scene. And we can recommend one of those. It's called Cleanup 3, for example. This is an extension that reduces unnecessary polygons and take hidden faces away from the scene. So you just push cleanup here and it's going to clean the scene. And also in this warehouse you can find other kind of extensions that are really helpful. We will list those under this video later on, so you can have some more examples.
So, but when you use these automatic cleanup extensions, you kind of have to be careful, because they might actually remove, things that are necessary for your model.
So always check your model visually on the screen if it looks good, or if it takes if it erases things that you actually need for the scene.
Right.
So this is now high level detail model that we showed before, this one. But we can also go to the multicolor one, for example, this one. So by reducing the textures here, by just simply erase them, as I do now, like this, I get solid colors instead in this model, as you see. And this, of course, will get better performance on the screen. And it's going to look like this. Not as detailed, but still good. Next level here, the solid model, is also quite simple to do. So you just select this whole model, you explode it, and you choose solid color, white for example, and you just put it on the whole model here.
So and now it removes all the textures basically from the entire model.
Exactly, and colors.
But the geometry is obviously the same.
Yeah, so this is when it's looking like this. And then simply you just export it as a KMZ file and you take it into CityPlanner. Next level here, the first level, the volumes, you can actually draw them in SketchUp as well if you want. You can use your original model as a form or background. So if we do like this, we make a group again here, puts this one in the top view, and we choose the pencil here.
And you're actually not using the perspective rendering in SketchUp now?
No, I'm using this one, the parallel projection, and this is easier to see lines instead of getting confused by some kind of perspective. Yeah. So we do like this, we stand in the top view and we draw just a simple shape around this one, and we have the options to do this very exact or not. And then we simply just extrude this one here. We can also refine it a little bit. Extruding this one. So as you see, I have the real model under it here, but the volume I want to import to CityPlanner is just as solid as this. So I go here, I erase the model behind, and I can only import this model into CityPlanner. And that's the first level of detail, the volumes.
And again, that's like maybe 12 faces instead of 130,000. But of course, it depends on what you want to communicate.
So you can actually use the original model for a lot more than just optimizing it. Next step is geolocation. That is also a very simple function in SketchUp. Instead of using a GIS-program for this, we can just take this one here. It's a geolocation function. This opens up a map, a real-world map. And by just choosing the location in this map that I know my building is going to be on, for example here,
Where are we in the world?
This is Sweden, Eskilstuna. I take the select region, I grab it, I go back here. So this gives me a piece of map in the scene with a geolocation. And after this here, I can move my model into the exact position here. Like this, for example. And now, when I'm exporting this one to CityPlanner, it's going to end up on the exact position that I'm choosing in SketchUp.
Right, except for the altitude, because SketchUp is using a different altitude mode than CityPlanner. So you will have to adjust its altitude to fit your terrain.
So basically just place it on the ground here after importing it.
Yes, and another thing to keep in mind is when you georeference with this method in SketchUp, you have to export as KMZ, because otherwise the georeferencing will not work. Because you're actually georeferencing in VGS84 coordinate system, but your background and city model will be in a local coordinate system, like a VRF coordinate system, for instance. So if you export as KMZ, we will do that transformation automatically, but if you export as Collada, CityPlanner will assume that it's already in the right coordinate system and won't, transform it to the coordinate system.
So this is how we optimize a model in SketchUp and taking it into CityPlanner.
Another way, of course, to do georeferencing is to export from CityPlanner and then import into SketchUp with the exporting tool here.
This one, export
and
3D.
If you export it here and then import it into your SketchUp scene, you can actually use that to do actual georeferencing as well. And then the altitude will be correct.
Yeah. Yes, the next step we're going to show here is actually clickable 3D models.
Yeah, how do we actually use them and make something interesting here? Now we have them optimized and smoothly running in CityPlanner.
Yeah, so as everyone know by now, it's that we have an object manager which all the objects are ending up in. So here I can find my model, number 3 there, this one. I'm choosing on click, which indicates what's going to happen with the model when I click on it. It's going to be a pop-up window. And I can choose here, for example, embedded code, that is a web page. I go here, I copy a web page. I go back to CityPlanner. I paste my URL address in here, like this. I close this window, and I try clicking on it. And this is when I'm gonna pop up then. So each model can have one info window coming up like this. And you can have as many as you prefer.
Yeah, and it could be, like we did now, an embedded website, or you can upload content to it, just like any point of interest window with images, text, documents, that sort of thing. One thing to keep in mind, though, is if you want all of these buildings here to have their own pop-up window, you have to add them as separate files to CityPlanner.
Yeah, as now they are one big model like this. So.
Right, so you would have to separate them into 4 files in order to make them clickable, individually.
Yeah. We're also going to show you another way of making clickable models here.
Yeah, so this is slightly more advanced. This demo uses some JavaScripting to hide layers and different parts of the 3D model when we click on it. So the model is actually composed of 3 parts. So we first have the base of the tower, then we have the floor, which is clickable, and then we have the top part of the 3D model of the building. So when we click the building initially, or the floor, it actually hides the layer which has the top part, and then with some fancy JavaScripting, we can navigate in interior in the model.
And we can go back to the origin by just back to overview here.
So that's something cool you can do with clickable models. It's slightly more advanced, so we won't go into detail here, but if you want to learn more about that, you can contact me. Okay. Now, one smart way of doing this optimization is obviously having someone else do it for you. So if you get models from external consultants or architects that you work with, make sure to have a requirement specification or a checklist for the 3D models that you want to use. So we have actually put together a quick checklist in the 3D modeling reference page available in CityPlanner. And this page is also linked below this video. So a quick checklist which you can hand out to the consultants doing 3D modeling for you. KMSAT Collada file format, triangulated geometry, and remove interiors and balcony railings and the stuff that Karin just showed us. File sizes, both for textures and the file and the geometry itself. Compressed files or PNG file formats and texture sizes. So if you follow these simple rules, you should do fine in CityPlanner. If you really want to dig into it, there's a long list of stuff that you can consider with your 3D models to further improve their performance. So this is linked below this video. So a quick summary what we've been discussing, and again, if you have any questions, feel free to ask them in the chat window or contact us after this webinar. But we have been talking about reducing faces, removing unnecessary geometry,
replacing those with simply geometry as transparent raster images.
Yes, exactly. Make sure textures are compressed so they download quickly, but also limit the resolution of the textures. Otherwise, rendering them will be slower.
And one last thing we can look at here, we can also check the model. Inspector here shows the actual size in megabytes. So this one is 4 megabytes. And this actually contains, as we said before, 4 houses. The one we were working with here was just a single house. So recommended is to import them one by one, actually, not doing like this to put everything in a big folder.
So less than 5 megabytes for all of those buildings. That's pretty good.
Yeah.
And then we've been talking about how to geo-reference in SketchUp, and also you can export a terrain from CityPlanner, and then exporting as KMSAT or Collada and use and upload them to CityPlanner. All right. Make sure to like this video and subscribe to our channel so you get a notification every time we do one of these webinars. If you want to suggest a topic for the next webinar, make sure to contact us, let us know. We also have a short survey which we would be happy if you could answer to help us improve and how we can improve these webinars.
Yeah, that's about it.
That's about it. Thank you.
Thank you.